Hello everyone, let us provide a solution to this interesting calculus problem under polar equations. We're asked to find the equation of the tangent line to the curve r equal to 3 divided by 1 minus sine theta at a point where theta is equal to pi. I'm going to present you two different ways to solve the same problem but in different videos. In this tutorial, I'm going to present you the harder way. Let's get started. First of all, I would like to find two values, r and dr over d theta. So let's start with r at a point where theta is equal to pi. R will be equal to, from that equation, 3 divided by 1 minus sine of pi. Sine of pi is equal to 0. 1 minus 0 is 1, so the denominator is 1. 3 divided by 1 is 3, which implies that r is equal to 3. Wow. Now I would like to differentiate it. If we take the r over d theta, it is equal to bottom times the derivative of the top. If you take the bottom, which is 1 minus sine theta, you multiply by the derivative of a constant, which is 0, everything will be 0, minus the top, which is 3, times the derivative of the bottom. You can see the bottom is 1 minus sine theta, derivative of 1 is constant, derivative of negative sine theta will be negative cos theta. So we are multiplying by negative cos theta. Divide by the bottom squared, which is 1 minus sine theta squared. Let's simplify this. This is equal to negative 3 times negative cos theta is 3 cos theta. Divide by the bottom squared, which is 1 minus sine theta, everything squared. This is dr over d theta. So what will be the value of dr over d theta at a point where theta is equal to pi? Let us evaluate it. Dr over d theta, let me write it down here, at theta equal to pi, this will give us to the top, cos of pi is negative 1, and negative 1 times 3 is negative 3. To the bottom, we have sine of pi, which is 0, right? 1 minus 0 is 1. 1 squared is still 1. So everything here will be negative 3. So you can see that dr over d theta at a point where theta equal to pi will be negative 3. So what can you remember about equation of a tangent? Remember, equation of a tangent is also equation of a line. In point slope form, we can write it as y minus y1 equal to m, which is the derivative at that point, times x minus x1. This is what? In rectangular coordinate. So I would like to interpret these terms in polar coordinate. What you should remember is that y is equal to r sine theta, right? You should know that x is equal to r cos theta. And m, in this context, is equal to what? Dy over dx. So I think let me remove m and write dy over dx directly. Dy over dx. Therefore, we can say that dy over dx is equal to, if you want to interpret it in polar coordinate, it is going to be dy over d theta, right, divided by dx over d theta. D theta will cancel d theta. Subsequently, you're going to have dy over dx, and we're going to obtain them here. So let us differentiate these two functions separately at pi equal to theta. Here, remember, both r and sine theta are all functions of theta, right? So dy over d theta is equal to, since we have product, we are going to apply product rule. Let me keep r constant and differentiate sine theta. Sine theta, if you differentiate it, you have cos theta. Plus, this time around, you keep sine theta constant. Then you differentiate r with respect to theta, which is going to be dr over d theta. All right, let's substitute everything. At a point where theta is equal to pi, remember, all through. So this will be equal to r. Already we have r. This is why I obtained r. R is 3. Right? So this is 3 multiplied by cos theta, which is -1. That is cos pi is -1. Plus sine of pi is 0. So 0 times whatever, though I know this value, which is -3. You see that here? Just plug it. Times -3. You see this is 0. This is -3. So everything here will be -3. -3. So I am done with dy over d theta. Now let us find dx over d theta. Should I do it here? Dx over d theta will be equal to keep r constant and differentiate cos theta. If you differentiate cos theta, you have negative sine theta. So everything here is negative r sine theta. Then you add, now we keep cos theta constant. Then we differentiate r, that is dr over d theta. Substitute everything. This is minus, what is r? R is 3. Sine of pi is 0. Plus cos of pi is -1. Then dr over d theta is -3. -3. Simplify everything here. This is 0. This is +3. +3. All right. This is equation of a line in rectangular coordinate, right? So since y, remember y is what? R sine theta. So let's just replace it here. We have r sine theta minus r sine theta 1, because this is y, this is y1. R sine theta 1. And this is equal to dy over dx, remember, is dy over d theta divided by dx over d theta. Multiplied by x, remember, is r cos theta minus r cos theta 1. And we are done. Let us substitute everything. The only 3 things we are going to substitute are this one, and this one. So y will remain r sine theta, minus r sine theta 1. Do we have r sine theta 1? Even if we don't have it, I know the value of r. The value of r is equal to 3. You can see that here. So we have 3 multiplied by sine of pi is equal to 0. This is equal to dy over d theta. Dy over d theta at a point where theta is equal to pi is -3. So we have -3 here. Divide by this one. Dx over d theta is 3 at a point where theta is equal to pi. Multiply by r cos theta. Then minus r, which is 3, cos pi is equal to -1. Let's simplify. This is r sine theta. This is 0. We move to the other side. This is -1. R cos theta. Minus is plus, so we have +3 here. Using this minus sign, we can expand. We have r sine theta minus r cos theta minus 3. Take this one to the other side. We have r sine theta plus r cos theta equal to -3. Factor out r. We have sine theta inside plus cos theta. This is equal to -3. Divide both sides by sine theta plus cos theta. Finally, r equal to -3 divided by sine theta plus cos theta. And hence, this is the equation of the tangent line to that curve, r equal to 3 divided by 1 minus sine theta, at a point where theta is equal to pi. So in our next class, I'm going to show you how to do that in a very simple way by converting everything into rectangular coordinates. Thank you for watching. Do share to your learning colleagues. Bye bye.